So, the video for the entire lecture ended up being too large, so I had to split this lecture into two videos. We're just going to continue where we left off with the first one. We've just seen the animation of the embryonic folding and how the lateral plate mesoderm is divided into two layers, and with the ends of the amniotic cavity kind of just coming closer together in the midline and sort of pinching off the yolk sac a little bit, and how the intraembryonic coelom ends up becoming the internal body cavity. So let's just recap the divisions of the intraembryonic mesoderm. Remember, we've got the paraxial mesoderm that's found on either side of the notochord. You've got the intermediate mesoderm that's right after the paraxial mesoderm before the lateral plate mesoderm, so it's in the middle. And the lateral plate mesoderm at the very end is divided into both parietal and visceral mesoderm, and each one of those is continuous with a part of the extraembryonic mesoderm. Okay, and in this picture, let's just see if you guys can identify the things. This is the neural tube. Right underneath it, you've got the notochord. On either side, you've got the paraxial mesoderm, and right after that, you've got the intermediate mesoderm. And here you can see the lateral mesoderm divided into an upper and lower layer with a cavity in the middle, which is the intraembryonic coelom that will end up becoming the body cavity. So each part of the mesoderm will end up becoming its own set of structures. So let's look at how these different parts will continue their development. So with the paraxial mesoderm, what happens is that it becomes arranged as segments. And if you remember when we looked at the video of the development of the nervous system, or initial development of the nervous system, at the end of the video there were these small square-like segments on either side of the neural tube. These are the subdivisions of the paraxial mesoderm that first appear in the cranial end, so they appear near the head first, and then they continue caudally, so they continue down the body. In the head, these subdivisions are referred to as somatomeres, which will give me the structures of the head. And from below the head, so anything from the head downwards, the segments are called somites. Now the first pair of somites appears on day 20. So you have one pair, one somite on either side, appearing on day 20. And then they will continue appearing at a rate of 3 pairs, so that's 6 somites per day, until they complete 42 to 44 pairs by the end of the 3rd week. Okay, so this is what the structure of the developing embryo looks like at this point. You've got the neural folds fusing here in the midline, and remember the fusion continues craniocaudally. And then notice how on either side of the forming neural tube you've got these subdivisions. And obviously this is below the head, so we're going to refer to them as the somites here. Okay, and again, just a picture view of what the somites will look like. Now, in week 4, what happens is what happens is the somites lose their compact structure. So initially they were subdivisions made of compact cells that are packed tightly together. And what happens is these cells become loose, so they kind of detach from each other, and they start migrating, so they basically change their original position. Okay? And this migration causes the somite to be divided into 2 populations of cells. A group of cells are located medially, meaning that they are closer to the notochord and further away from the surface of the body. These will end up becoming the bone and cartilage of the segment involved. Okay, so they give me the bones, for example, of the limbs, bones of the vertebral column, depending on where you are in the human body. So let's say you're looking at the somites that are found in the upper back. Okay, those are probably going to give you the vertebrae in that region. They're going to give you the bones of the upper limb. But if you say look at the somites that are lower down, they might end up giving you the bones of the pelvis, the bones of the lower limb, and so forth. The population of cells that are located laterally, meaning that they are further away from the notochord and closer to the surface of the body, this population of cells is called the dermatomyetome or the dermomyetome. These give me the muscles and dermis of that segment. So the dermis is the inner layer of the skin. Remember how I told you that the skin is divided into two layers, an outer and inner layer? The dermis is the inner layer of the skin. So the inner layer of the skin plus the muscles will come from the lateral population of cells called the dermatomyetome. All right, same concept applies. If they're in the upper back, they give me the muscles and dermis of the upper limb, upper back, vertebrae in that region, and etc. Okay, so this is what the somite division looks like. You've got the neural tube here, and you've got the notochord down here. So notice how you have a group of cells, the ones that are in yellow, that are closer to the notochord. So this is the sclerotome, okay, which is going to give me the bone and cartilage of the segment. And then the dermomyetome, okay, which is further away and closer to the surface of the skin, closer to the surface of the body. This is going to end up giving me the muscles and the dermis, all right? And remember, the epidermis already developed from the ectoderm. So essentially the skin comes partially from ectoderm and partially from mesoderm. Now, from this point forward, we're just going to look at or name the structures that the mesoderm becomes. I don't need you to go into the details of how these organs are formed because you're going to get them, next year and the year after with the specific systems as you study them. All right? So for now, I just need you to know that the intermediate mesoderm becomes the kidneys and the reproductive organs. Okay, so make sure you can identify where the intermediate mesoderm is, and remember that it becomes the kidneys and reproductive organs. The how of it will come later on, way in the future. All right. The lateral plate mesoderm, on the other hand, develops into the lining of the body wall, specifically the lining of the pleural cavity, the pericardial cavity, and the peritoneal cavity. And just really quickly, the pleural cavity is the cavity that contains the lungs. The pericardial cavity is the cavity that contains the heart. And the peritoneal cavity is the one that contains the intestines and organs of digestion. Okay? So all of these organs, in addition to, being contained within the cavity that was initially the intraembryonic coelom, they also need a specific protective lining which originates from the parietal mesoderm. The splanchnic mesoderm, which is the other layer, the layer that's found lower down, okay, this will end up becoming the heart and its blood vessels, so the aorta and all those things, plus the muscles of the GIT. Okay, so essentially the internal organs, all right, or some of the internal organs, not all of them. So, again, you just need to know what each one becomes. The details will be taught to you later on. Okay, so this table just summarizes all the derivatives of the mesoderm. Okay, you've got the paraxial mesoderm becoming the segmental bones, muscles, and dermis of the skin. The intermediate mesoderm, remember, becomes the kidneys and reproductive organs. And the lateral plate mesoderm becomes the serous membranes of the body cavity if it is the parietal layer, or it becomes the heart, blood vessels, and muscles of the GIT if it is the splanchnic layer. Okay, now the last layer we're going to look at is the endoderm, which is the innermost layer of the trilaminar disc, and this one's easy because what it does is that it becomes the internal lining of the body organs, specifically organs that have cavities. And the reason for this is that if the organ has a cavity, then that most likely means that it has something flowing through it. So maybe blood, digested food, air. Okay, so whenever an organ has something flowing through it, that means that it has a chance for friction to happen. So to prevent this friction from happening and to make sure that the organ is protected internally, they need to have an internal lining as well, and this internal lining originates from the endoderm. So this includes the lining of things like the GIT, the respiratory system, urinary system, and so forth. The endoderm also gives me two organs, which are the liver and the pancreas. And these are what we call accessory organs of digestion. They're found in the GIT. And hopefully when you take the development of the GIT, you're going to know that these two organs have a very specific pattern of development. Okay, so in summary, this is what the this is what the embryo looks like at the beginning of the embryonic period. So clearly you can see that, even though you can make out some features, like, this expanded part is obviously going to become the head. This could possibly be a limb extension. All right, we've got a couple of bulges here that might be the beginning of the heart and so forth. The somites are starting to appear here, okay? But there is no distinct structure in terms of what the developing embryo looks like. Now, in comparison, this is what the embryo looks like at the beginning of the embryonic period, and this is what it looks like at the end of the embryonic period. All right, so you can see the difference how the different body parts are clear now. You've got the head, there's a little bit of a neck here, thorax, abdomen, there's a full torso. The limbs are clear and they've divided into, the feet and the legs and the hands. You can see the toes and fingers. You can even see some facial features. So at the end of the embryonic period, there is an actual structure or fetal form. And then further development and changes will happen over the next period of development. Okay, so that is all I have for you today regarding the embryonic period. And as usual, I will leave you with a positive quote to remind you that even though sometimes we have bad things happening in our lives, and clearly we're going through a lot of bad things right now, but you never know. Sometimes they put you directly on the path to the best things that ever happened to you. So try not to look at bad things negatively. Whenever they happen, try and find the hidden blessings in them. And you never know. You might end up being happy that the bad thing happened to you. So thank you so much for joining me. I hope this session was useful for you, and I will see you guys next time.